Okay, in this session, we're going to go through control flow. So we're going to talk about looping, and we're going to get hands-on with the code and try to apply this in a couple different ways. And then after we go through this slide, I'm going to stop the recording and we're going to work together through assignment 1. So if you miss this lecture, reach out to me. I'm happy to work through that with you. Okay. Control flow is how your program flows and executes. We're going to talk about 4 different types of control flow that navigates where your program and how your program is executing and what decisions are being made. We're going to talk about conditionals, so if, elif, and else. We're going to talk about iteration, loops such as while and for, and then we're going to talk about jump statements, so ways to manipulate the way breaking out of those loops, essentially. Then we're just gonna touch on nested loops. Okay, so conditionals. There are times in which you are writing a program where we need to have the ability to check if certain conditions exist. And we can use, you can see highlighted in blue here, the if statement to do that. So the if statement executes code whether a condition, based on whether a condition is true or false. So the way that you would write that in Python is you would say if. If is the reserved keyword. You can't use if for anything else. It's the way that we know that it's an if statement, and it operates the same for me in my code as it does for you. So you would say if space, and then you would provide some type of condition that at the end of the day evaluates to either true or it evaluates to false. In this case, the word condition is actually a variable, and that variable would hold the value of either true or false. In order to say that, in order to tell the program that you are done writing your conditional statement here, right after the if statement, you end it with a colon, these 2 dots here, you end with a colon. And then on the next line, whatever is indented executes in the program. So maybe in other programs you've worked with, they've used curly braces to contain the code block for execution. In Python, we use indentation. So indentation is very, very important to Python. If your indentation is off, you're probably going to get some errors in some ways that you might not expect. Okay, we're going to talk about if, elif, and the else condition. And I have code as we go through here. So the if statement, up here we have the if statement. We have if x, it's to set a value for x. Let's set x is equal to 5. That's fine. About that. The if statement is what we have here. If x is greater than or equal to 0, print x is positive. The Boolean expression after if is called the condition. So this is the condition. Before we had, in that previous code, we had if condition, print I am in the loop. We could set condition equal to true or equal to false. Equal to true. If it's true, it says I am in the loop. If we set it equal to false, it says nothing. It exits this if condition when this evaluates to false does not get executed. We can do the same thing here. If true, I am in the loop. If false, okay. So if it's true, then this indented part of the conditional statement gets executed. So if true, print 1, print 2, print 3. If it's not true, as you saw when this was false, then nothing happens. So if it's not true, then nothing in fact happens. And the code would continue as is. So we can say the code continues as is. If false, print 1, 2, 3. Maybe we had something else in our code that prints the end of this program. This still executes. So anything outside of this if statement would still execute. But if this was true, we would get 1, 2, 3, and the end of this program. There's really no limit to the amount of statements that you can put within the body. This is the body. Sorry, this is the body of the if statement. By the way, when you highlight your code here, you'll see these 2 dots. Those are hidden characters, and those represent spaces. So that shows you that 1 tab in my code is actually equivalent to 2 spaces. Well, it wasn't one. There we are. So tab or, and that leads me to this last point, got a little bit ahead of myself. Python relies on tabs or spaces to indicate the executable body. So this part of the body is within the if statement. I'm going to pause for a minute. Is this making sense so far? Any questions so far?
Sorry. Does for the tabbing in, does that still work for nested statements?
It does. That's a great idea. Let's look at nested statements. Let's say this is fine. So for the tabbing in, everything, if we want to say if true, then do something, and then we want to put another if statement within that if statement, you see that these have to be 4 over now, 4 spaces or 2 tabs. I'm just going to say tabs from now on. It's just a little easier. So this if statement, this would be outside of the this top if statement. If we did 1 tab over, this is inside of the if statement. Fun fact, if you want to backwards tab something, you can press the shift key and then tab, and it'll move it over. And then if you highlight everything and press the tab key, it'll move it forward 1 tab.
So there's no overarching brackets or parentheses for a whole deal, or put an end at the end of that nest. You just use the spacing? That's
correct. There's no end. There's no curly braces. There's no brackets. It's just completely dependent on spacing, which is good and bad, but it can cause issues, right? Let's make some spacing errors. And they can be hard to check. Let's see if this. Nope, that's not a spacing error. Let's do this. This will be a spacing error. Should throw, no, I did 1 space. Let me try, that's throwing an error for a different reason. Oh, here, let's just do this. This will be really simple. Let's try to tab this when there is, oops, nothing. There we are. So unexpected indent is what you may see from an error perspective, where I tabbed this out, but it doesn't understand what body this is supposed to be a part of, what loop or iteration this is supposed to be a part of, because it's not inside anything. So to fix this, you would just tab that back. I believe you can put curly braces if you want to. Let's see. Feel like, no, maybe not. I was wrong. We tried that. Okay, I'm trying to get this to, if we tabbed this over again, this would also throw an error. Oh, nope, that didn't do what I expected it to. Good question, though. Did I answer that?
Yeah, you answered it.
Perfect. Any other questions so far on if? We're working primarily, by the way, with true and false, just to show how that works. But of course, in your program, you're probably going to be using it to make decisions. So you're going to have A is equal to 1, 2, 3, and B is equal to 4, 5, 6. And you want to say if A is greater than B, then print A is greater than B. So you may be trying to B is greater than A, print A is greater, well, B is greater than A. You can see that's a program's going to do exactly what you tell it to do, even if that's wrong. So print B is greater than A. Or you may have two things. Animal 1 equals cat. You may have animal 2 equals dog. If animal 1 is equal to animal 2, print the animals are equal. Let's put this as a cat. So in your program, your conditional statement here won't necessarily be true or be false, but it will be a statement that evaluates to either true or false. That's a Boolean expression. Occasionally, it can be useful to have a body with no statements in it. So in Python, you cannot create a statement with nothing in it. So if I said just if true, and then I wrote the rest of my program, print the rest of my program, that would not work. It's a unexpected indent after the if statement, because it's expecting code to be indented and executed here. So you cannot leave this empty. If statement block cannot be empty. However, if you do want to create an if statement that is essentially empty or does nothing, you can use a keyword called pass. This is sometimes used when you're developing placeholder code and you're not yet ready to implement it. So maybe you're doing some object-oriented programming and you're designing all these methods and classes that you want as part of your object, and you're laying them all out, and you want to kind of test that they functionally work without putting all the code in them, then you can use the pass. You can use pass to say if x is less than 0, then pass. I did not define x. Let's say x is equal to -1. I might have to sneeze here in a minute. Pass. But you can see that nothing happened. And if we took that same code and we said x is now equal to 5, which is, of course, greater than 0, also nothing happens. So it's sort of the same. It's the same outcome. However, in this case, what's happening in the control of the program, the program and where it's executing, is x is getting set equal to -1. We're evaluating if x is less than 0. We're actually entering this if statement, and then we're exiting the if statement because of the pass. Whereas in this situation, when we say x is equal to 5, if x is less than 0, we're actually not entering this if statement. This evaluates to false, and we don't even enter this block of code here. The program doesn't even know that the code inside this is pass. It doesn't care. It doesn't need to execute that. It just moves on. It jumps out of that and moves down to the next line of code. Does that make sense? In Python, we also have an else statement. So there are some situations where we want to use if, but there's also an alternative that we would like the program to execute. One of two different situations. There's two possibilities. And this conditional expression determines which of these two get executed. So in this case, we have x mod 2 is equal to 0. Then we're going to print it is even. Else we're going to print it's odd, because everything that is not mod 2, or everything mod 2 that is not equal to 0 is an odd number. So we can try a number here, x equals 2. And in this case, it prints x is even. So the control flow of the program, x takes on the value of 2. Then we take 2 divided by 2 and check the remainder. The remainder is in fact 0. So x mod 2 is 0. 0 is equal to 0. Then we print x is even. Let's set this to something else. Let's set x is equal to 3. When x is equal to 3, the flow of the program will be that x takes on the value of 3. X references the value of 3. If x mod 2 is equal to 0, so x mod 2 happens first. 3 divided by 2 is 1 with a remainder of 1. The remainder is 1. 1 equals double equals 0, returns false, because 1 double equals 0 is in fact false. 1 does not equal 0. Since that returns false, we move on to the next statement. And the next statement is an else statement, which says, anytime the first statement is false, do this instead. And so what it is going to do is print x is odd. So this is how the logic of our program is determining whether a number is an even number or it's an odd number. It doesn't magically know that it's an even number or an odd number. We wrote a script. We wrote a program here for how to determine if a number is even or odd. This is how the computer makes that decision in the program. Okay, so if the condition is false, the second statement is executed. And since the condition must be either true or false, one of these alternatives will be executed. So either this first alternative is executed or the second alternative is executed every time. These alternatives can be called branches because if you have a lot of them or a complex program, complex control flow, you can actually diagram them out and it looks a little bit like a decision tree. So you can follow the flow of execution through the program. Oh. Typo here, there we are. Sometimes there are more than two possibilities. There's numbers, maybe we're not doing even and odd, but we have this situation where we have x and y, and we want to know if one is greater than the other one. However, they can also be equal to each other. So in this situation, we have three scenarios that we need to evaluate. If x is less than y, we want to do one thing. We want to send our code one direction. But if x is greater than y, we want to apply a different set of code, a different piece of logic. In all other situations, which is If it's not less than y and it's not greater, and x is not greater than y, then it must be equal to y. In all other situations, i.e. when they are equal, we'd like to do something else. In that case, we can use something called the elif statement, which elif stands for else if. So in other maybe structured programming languages, they might spell out the word else if. In Python, we just squish them together and make up this word called elif because we're a little lazy. So if, elif, and else. This can be called a chained conditional because we're going through this different series of conditions. Only one of these branches can be executed. And there is no limit to the number of these branches. So only one of these can be executed. So we're either executing this print statement or this print statement or this print statement. There's sorry, trying to think of what to touch on next. There's no limit to the number of these. You know, I have 3 in this one. Let's do just if a plus b is greater than 100. Let's do elif a plus b is less than 100. Actually greater than, let's do 250. Elif a plus b is greater than 50. That'll be an interesting one to add there. Elif a plus b is greater than 10. Okay. So there's no limit. Okay, first of all, there's no limit to the number of elif statements that you can add here. So we could have 100 elif situations and scenarios in which we created blocks of code to do things. What do you guys think is wrong with this code? I mean, it will run, right? If we have an a and a b value, a equals, let's say 100 and b equals 50. What do you guys think is gonna, let me clear this output here. What do you think is gonna print out here?
Three of them?
Say again.
I believe 3 of them would print out the 100, 50, and 10.
150 and 10. All right, let's try it. Oh man, what happened to our 50 and our 10? We're only getting 100. Let's make sure, let's debug this. Let's copy this, put it down below. Let's try it with just 50. And let's see if that condition prints or not. All right, well, logically, there's nothing wrong with that. Let's try it with 10. Oh. Okay, that seems to print. Why are we only getting 1 here?
It's because the first statement's true, so it doesn't care about the rest of them.
That's right. So your first statement that it finds to be true, it says, oh, that's the code that I'm going to execute. And it pops inside of this block. So we have A plus B is 150, which is in fact greater than 100. It pops into this block here, executes anything that's indented within this if statement block, and then skips the rest of the code. So it will actually not check for any of these other conditional statements to be true. So be mindful of that when you are writing your code. If we wanted it, in fact, to check for all of those, we would have to do something else, like have separate if statements. Oops. So in this one, we have if A plus B is greater than 100, do this. If A plus B is greater than 100, do this. If A plus B is greater than 10, do this. And I know I've got, ignore my text there. There we are. In this case, they all evaluate because these are separate if statements. But if you use elif or else, elif and else can only be used with an if statement. And that means they're connected to that if statement. This entire code block is related to each other in that it checks each of these conditions and says, is this true? If it's true, execute this. If it's false, move to the next condition. Is this true? If it's false, then move to the next condition until it finds a true statement. Okay, I think I explained that. So only one of these branches, because of that, only one of the branches will be executed. There must be an else clause at the end of this statement. So if you use an elif, let's try it. And let's get rid of the else. Nope. I lied. You do not have to have an else statement at the end. I stand corrected. Nope. You can do it without an else. Do not need an else statement. All right, apparently we're learning together. Okay, maybe I got ahead of myself. What happens if more than one statement is true here? So this is asking the same question. But what's going to be the output of this piece of code here?
Only the first true line is going to print or execute.
That's right. So when we run this, the first true will execute. And inside that true, we have a print statement. So the output will be 1. Okay. Let's look at a example game here. How might we actually, those are great concepts, but perhaps a little dry when we're just looking at numbers and comparing them. How would we actually implement this in something meaningful that we're trying to build? Let's create a game where the computer is going to ask us to guess a random number between 1 and 10. And the computer is also going to pick the computer is going to pick a number between 1 and 10, and it's asking us to guess it. So we're going to import a package here, a Python package called random. And random allows us to call this method, this function called randint, and we pass 1, 10, which means it can range between 1 and 10. And when this executes, it returns a number that's between 1 and 10. Let's look at that. Oh, I did not, did you see what I did there? I did not run this cell yet. You can tell because this square brackets are blank. There's, if we scroll up and we see these square brackets have a number in them, 38 or 37. These are blank, which means I did not run that yet. And it says name random is not defined because I have not yet imported this. So you do need to import that before you use it. All right, so if we run this, I probably don't need to re-import that every time. I'll just leave it up there, get rid of that now. So we get 10, we get 1, we get 10, 7. So it's going to generate some number between 1 and 10. What we're going to do is we're going to take the output of that value. So when this code runs, it hits this line and it says to the variable number underscore 2 underscore guess, assign the value of this, generate a random number right now, and take that and assign that to, store that here in this variable. And then it's going to ask us for input. It's going to ask us to guess a number between 1 and 10, and it's going to cast that to an integer because input default will be a string. And so we're going to cast that number to an integer and store it in the variable user guess. If user guess, what I'm passing in from input, is equal to the number guess, then it's going to print congratulations that I correctly guessed it. If it is not, if it is less than, it's going to say, oh, too low, maybe try again. And it's going to say too high. You know, I'm not even going to put the try again actually because we're not in a loop. It just executes one statement after another. So let's try this. So we're going to guess a number. What should we guess?
7.
All right, 7 it is. Oh, too high. We can run this again. Let's try one more. Guess a number.
6.
Oh, too high again. So we could do that all day. But when we get to the next looping structure, the problem is every time we rerun this cell, the number changes. The number to guess changes. So I think if we just kept running this and putting in 7, we might be able to actually guess it. How do we ask the program to actually give us another attempt at guessing this number? We can try that when we get to for loops. So go ahead and try this conditional. Write a program that asks the user to input a number. You can kind of copy and paste this code, do it just like this, and then print whether that number is positive, negative, or 0. And maybe if it's non-zero, modify that to do even or odd. Let's spend 7 minutes on that till 6:50. Yes, I could have. Nope. I will share this with you guys, by the way, if you don't. I saw somebody asked for that, so if you don't already have this. Okay, perfect. Somebody shared it.
How do we get the 2 mod thing that we did earlier for the odd or even?
That will be 2. Let's just scroll up. You know what? I'll just do this. Fun fact, if you put a comment, so a comment is, I know we haven't talked about comments yet. A comment is anything in green you see here. Essentially, whatever is in green is ignored by the program. So it just ignores it completely. So you can put whatever you want after a hashtag. It's called a single line comment because it only exists for one line. The program's going to ignore the program that executes the code is going to ignore this. So this is not code. I wouldn't call this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I would not call this 12 lines of code, for example, because this is not code. I would call this 1, 2, 3, 4, 5, 6, 7, 8 lines of code, 8 lines of code. So the fun fact I wanted to say is that if you type something in a comment and you have Gemini turned on your notebooks, you can say determine if a number is true or true or false. Sorry, determine if a number is even or odd, and it will probably generate some code similar to what you are looking for. I do think it's important you guys learn the fundamentals and not necessarily just how to have AI write all your code for you, but it is helpful. It is useful at times when you're trying to figure out something like the modulus operator. So it would be number modulus 2. If we divide something by 2, if that remainder is equal to 0, then it's an even number. And if the remainder is not 0, so if 2 goes into a number evenly, then it's an even number. Or goes into a number evenly. Goes into a number and there is nothing left over. So 2, 4, 6, 8, 10. And that would mean that our modulus is 0. Does that make sense? So if we had 10 modulus 2, you'll see that's 0. If we had 100 modulus 2, that's 0. But if we had 99 modulus 2, that is 1. Or if we had 87 modulus 2, that is 1. So it's always going to be either 1 or 2. If we did 0, unless it's 0. Okay. What do we think here?
I think I got it, but now it's looking like if I do pick a number between 1 to 10, and if I pick 3, it looks like 103. Or if I do 5, it's like 105. It looks like super close. Am I supposed to do something else?
Looks like 103 or 105.
Or like 106. If I put a number in the input box and I press run, it'll come out like it'll say even, but then it looks just like I'm picking 102, 103, something like that.
Oh, okay. So let's do, so first we need to collect our input. My input or user input equals, we're going to ask to enter a number. And we can enter 1, and we can output that user input, and we can see, oh, we in fact do get 1, or we in fact do get, you were saying 100. But this is, if we do type on this, we're going to see that that's actually a string. So we're going to have to do something about that. In order to fix that, we're going to cast it to an int. And now if we run type on this, we have an int. Okay, so that's the user input piece. The next piece is we want to print the number if it's positive, negative, or 0. This already gave me, that annoys me sometimes. Already gave me the answer. I would rather actually walk through that, but this is fine. If user input is greater than 0, we're going to print it's positive. If it's less than 0, we're going to print it's negative. So 100 is positive. Negative 100 is negative 0. Were you guys able to get this piece? Okay, great. All right, I don't want to get to that part yet. I want to write that ourselves. There we are. So now we're going to modify this to print even or odd if the number is non-zero. So we can, how might we do that? Where do we start?
Go ahead.
Isn't it just like you were saying, have it divided by 2, and if the remainder is 0, then it's even. If it's not 0, it's odd.
Let's try that. So let's say if, and I'm going to change number to user input, just like that. Yeah? Okay.
Yeah.
We're going to try it. So let's try it on 100. The number is positive and it's even. Let's try it on 101. The number is positive and it's odd. Let's try it on negative 100. Oh, it says it's even, and we're supposed to modify it. Oh, not 0. Sorry. Let's try it on 0. It says it's an even number, but
Because it's always going to be 0 on 0.
It's always going to be 0 on 0. That's right. So how do we modify this to, how do we make sure that this code meets our requirements, which prints even or odd only if the number is non-zero? How do we make sure that this block of code
Could do
only, yeah, go ahead.
For 0.
How would we do that?
So if like after the number is odd, or I mean the number is even, if you added elif, and then if it's equal, user input equals 0, the number is 0.
Print here. I am trying to, there we are. Print the number is 0. Okay, let's try this. So we got the number is 0. Let me change this to the number is 0. We are not determining odd or even for some reason. We're just not going to do that.
Shouldn't we just put that else if that we just added as the very first one, so that it, because as it's going down, it's hitting that first one, modulating it, it hits 0, and then it skips the rest. So if we put the user input equals 0 as the first one, it'll do that one first.
That's exactly what happened here. So we can see that this code ran and we got the number is 0 from this statement here. But even though we put user input as 0, we actually didn't get the number is 0. We are not determining odd or even. We in fact got the number is even, because user input modulus 2 is equal to 0 when the number is 0. So let's try and swap those. Let's do that. So we're going to do a elif here instead. And we have to start with an if. Let's try this. 0. Ah, we got it. Great. A different way to do this, by the way, if just a slightly different approach. I'm going to say same code, different implementation. Is we could have, instead of, if we didn't need to print anything, we could have said if user input is equal to 0, then do this as a nested if statement. So we'd say if user input is equal to 0, does not equal 0. If user input does not equal 0, then do these statements here. So let's try this out. Let's try 100. It's positive, it's even. Let's try 101. It's positive, it's odd. Let's try negative 100. Positive, even. And let's try 0. Oh, the number is 0. So the difference here is we didn't have an executable code block for when it was 0. We just skipped over that. Does this make sense? Okay, you can put if statements inside of other if statements, so we can nest them together. Everything inside, this is all contained within the block of this if statement. If user input is not 0, so any situation in which if it's 1, if it's 100, negative 100, we're going to do these things. In the case that it's 0, we're not going to do anything. Okay. Trying to decide if we should take a break or talk about, we'll take a short break. We'll take a, let's take a 4-minute break. Come back at 7:05. I do try to break every hour. Okay. Let's talk about for loops. So in Python, we can use for loops to repeat segments of code, repeat a block of code for every element in a list. So if we remember, we had this grocery list we were trying to build at some point. So say we have the this shopping list, and in it we have apples and bananas and cherries. And we want to, for every item in the list, print that we need to buy an item. And we could, of course, do it this way. We could say, I need to buy in print statements, by the way, just a note about print statements. We can print strings, text. We can print text. We can print text followed by code. Print text 1, 2, 3. We can also print something called format print to print code inside of curly braces. So when you do print and you say F and then followed by 2 strings, this is the format print. So print F followed by 2 strings, and you can put text in here. But the real value from that statement is when you do print F and we say text, and then anytime you put up these curly braces, you see that they highlighted purple. Anything inside of those is just executable code. So we could do our 1, 2, 3, text 1, 2, 3, or we could say my variable equals Emily. We could say print F, my name is my variable, and it actually executes that code. Or my variable plus last name, right? Last name. I confused it with the double quotes. There we are. Space last name. Okay. So we're going to use that. We'll talk more about print statements, but we're going to use that here. We're going to do print F, and I need to buy. And we could say shopping list at 0. We could say I need to buy shopping list at 1. There we are. I need to buy shopping list at 2. Essentially, I need to buy the first item in my shopping list, the second item in my shopping list. I need to buy the third item in my shopping list, which is at position 2. And it would say I need to buy apple, I need to buy banana, I need to buy cherry. We could do that, but since we're saying I need to buy and the item for every item in our list, we can simplify this code by using something called a for loop. And the syntax for this is for item in sequence, and then the code that you want to apply to each item. So what this actually does is if we say for item in shopping list, print item, let's just print them out and see what this does. So this is as simple as we can make this. It would print each item in the shopping list. Item is the word that you choose. This is a variable name. This is like saying sorry. This is like saying item equals, shopping list at 0. And then item equals shopping list at 1. And then item equals shopping list at 2. Maybe I'll go through that a little more. So we have item. Item is just the variable name. This is the variable name that we are creating. We could have called this whatever we wanted. And this would work as well. It would do the same thing. Save yourself a little bit of heartache and maybe call it something logical so you understand what you're working with as your code gets complicated. And then in shopping list, in means iterate over every single item within this shopping list. Just like the if statement where we had if true and then we had to end in this colon and we had to have, some information in here. The for statement also ends in this colon. And it also has the syntax of indentation. So this is the block of the for statement. Everything inside of this block will actually be executed. So this print item. So this happens iteratively. What happens is we have our code and it's running. We have lines of code up above and lines of code down below. And when we hit this for statement, it'll say for item in shopping list. And then it'll pop into this execution block of the for statement. And it will say, and at that point, item takes on the value of the first item in shopping list. So item takes on the value of apple. And then whatever you choose to do with item happens within this block. So in this case, we're printing it. Then once all of these statements finish inside this for loop, we go back to the beginning and then item takes on the second value. The positional element shifts to the next item. So item becomes banana and then this print statement executes and then item becomes the third item. So the second index, which is the third item in the list. So item becomes cherry. So if we wanted to, instead of copying and pasting these print statements 3 different times, we could simply say for item in shopping list, print format string here. I need to buy curly brace item curly brace. And this would in fact tell us with just this one piece of code here that we need to buy all of these items. So this reduces the redundancy of your code, the amount of times that you're copying and pasting the same code that does the same thing. Sorry, this should be with, oh no, it's fine here. I thought I had while loops and for loops broken out separately. We'll get to that in a bit. Any questions so far? Let's do an example. So up here, we had this game. Let's modify it. I'm going to ask you guys to we're going to do a different, you try it, actually. Oops. We had this code previously that asks the user for a number and outputs if they were too high were correct, too high, or too low. I want you to modify modify this code so that it is so that the user gets 10 tries to guess the number. After the 10th try, report that they are out of tries and lost the game. You will use a for loop over number of tries to do this. All right. I'll put that in the actually, you try it. Okay, spend a few minutes on that. Let's spend this might take a minute. So let's go until 7:25. So spend 7 minutes. All right, how are we feeling about this one? Let's implement the you try it. Oh man, we can start with the code we're working from here. Let me just separate that here. Okay, so let's work with this code. We're going to generate a random number. That's the number we want people to guess. And we have a user guess a number that we've guessed between 1 and 10. And instead of saying, oh, too low, too high, we actually want to say too low, try again. And we want to say too high, try again. And in some situation, which we'll figure out when we get there, we also want to say print you are out of tries and have lost the game. Try again next time. Okay. And we also know that at some point we need to track number of tries. What did I say? Number of tries equal to 10. Okay. At the beginning of the game. Here's a boilerplate for starting. How do we modify this so that and I might have put some of these in the wrong place now that I'm looking at it, but how do we modify this so that we continue to ask for user input using something like a for loop? I'm actually going to move this up here. There.
I copy pasted that user guessed equals and input line at the end of my loop if it was incorrect. So
Perfect. So you had a for loop.
Mm-hmm.
And what did you loop over?
While number of guesses is less than 10. That's what I set my loop for.
Okay, so you used a while statement.
Yeah, and then for every time it was wrong, it would just increase 1.
Okay, that makes a lot of sense. We can definitely do that. I'm going to put that down here. So you did while number of guesses is less than 10, and then you said do the stuff here. And then you basically asked for user input again at the end of the code. So let's copy this down and look at that in a little bit, actually. I'm going to jump back up and see if we have any ideas for how to do it with a for loop. And then I'm going to talk about what a while loop is, and then we're going to come back to that. Let me just... this is fine. We'll fix that. Okay. How would we do it with a for loop? Now that I'm thinking about this, I don't know if I gave you guys all the tools that you would need to implement this with a for loop. Maybe that's... Let me just hear you guys' thoughts. Any thoughts on how to do this with a for loop?
I put some stuff in the chat. Some other folks are too.
Perfect. Oh, sorry, guys. Yeah, definitely tell me if you do that. It doesn't notify me other than an indicate. I don't hear a sound or anything. Okay. Okay, so we got a while loop, for count, guess in count.
So like what I was saying there was just like, can you count the guests and the guest count? So like you know, for fruit and basket or whatever.
Yeah, we can do that. We can do a for I in, well, let's try it. Let's look at that. I'm going to just move this down so we can simplify what we're looking at without looking at this whole. We have a thing called number of tries equals 10. And we want to see if we can do for I in number of tries. And we want to, let's just print I. It's good exercise in debugging and see what this does. Oh, I had a typo. No, the typo was here. There we are. Gotta spell them the same. Oh, int object is not iterable. So this is number of tries is an integer that gets stored with this variable name. It is not a list of numbers 1 through 10, though we could convert it to a list of numbers 1 through 10 by using something called range. I have range later in the slide, so that was one of the, I apologize. So let's list of numbers in number of tries, long variable name, range number of tries. Let's just look at this for a second. Tip for you guys, if you ever just want to run a certain part of your code but not another, a certain piece like down here, you can highlight it, and on a Mac you can press Command / and that will either comment your code or uncomment your code. When your code is commented, we know that comments don't run, so it's actually ignored by the program. So when I run this, I can see that it outputs the range here without running this whole for loop, because I just wanted to set that aside for a second, and then I can highlight it again, press Command, or it might be Alt or Control on a PC. You might have to test it. Hold that button, and at the same time the / It's a useful piece. Okay, so we saw that it's actually just giving me the generator for that, which you're not actually seeing the list of 1 through 10 numbers. Let me do something else. There we go. Okay. So if we say range, we use this built-in function in Python over the number 10. So range of 10. I'm going to have to make this a list for you to actually see the output, or I won't describe what a generator is, but it won't output it unless I convert it to a list. So you can see that we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And now if we use that, we can iterate over that in a for loop. Oh, sorry. We have to iterate over the list here. There we are. We say for I in list of numbers in number of tries, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's try that. All right, we have to move all this code up here now. We have to create a range. Okay, so we have a list of number of tries. And then we're going to iterate over that list. Okay, so for that, then we're going to move this code inside here. We're going to check, congratulations, too low, try again, too high, try again. How do we get more input from the user?
Put the input in the loop.
Put the input in the loop. So we are going to, where should we put it in this loop?
I put mine right after the try again.
Right here?
Yeah.
All right.
And then you'd probably also have to do it on too high.
Perfect. Yep. That'll work just right. So, oh, sorry. I forgot my colon. So it gave me an error. Here's what it looked like before. I said for I in list, number of tries, and then I had all my code here. It threw an error. It says syntax error, that it expected this colon. And it actually tells you what line this is. It's helpful if you have line numbers on the side here. See if this does it. Oh, it didn't do that. So I'm sure there's a way that you can do that in this notebook. But if you counted down 15 lines, you would find yourself here. It's more helpful if you have line numbers on the side. And then it says, hey, it expected an indent, and it tries to be as helpful as it can. This the Python interpreter tries to be as helpful as it can until it even gives you a little caret, and it says, this is where I ran into that error. I ran into the error right here in the program. And so we look here and say, oh, yep, you're right. I forgot my syntax there, which says now start the for loop. Sorry, I keep hitting that. Guess a number between 1 and 10. Somebody guess a number.
Five.
5. I also saw 8 in the chat. 5 was too high. Oh, so I'm not going to guess 8. Guess another one. Got 4. Too high still. Guess another one.
Pick number 3.
Number 3. Oh, still too high. Interesting. What's next?
1.
1. Oh, good. Oh, no. But it now says, congratulations, 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 congratulations. And then it says you are out of tries. You have lost the game. So we're going to, okay, this one I just made a mistake. This should have been in a else. That wasn't the point I was trying to make there. There you are. Actually, I don't know if that's exactly how we would do that. I'll leave that there. Maybe you guys can debug that in your free time. However, what we're going to talk about next are while loops, which might be a solution for how we can make it not print congratulations every time. When it finds the number, when we found the number, we actually just wanted to exit the program. What happened here is it's going to keep going through this loop until it gets to 10. So even though we said print congratulations, the program is executing in the way that we told it to, which is iterate over all 10 of those numbers. And if user guess equals number to guess, then print congratulations. So that may not necessarily be what we want from a user experience. So how do we do that? We have a different tool in our tool belt called while loops. Oh, there's the range function. I apologize. A range function, we can use range to generate a sequence of numbers. So it's a little disorienting, sorry. So we can say for I in range, and you can actually pass your number here. So instead of creating that variable and going through all of that ceremony, we can actually pass range here, and then we can print I. So we can, and maybe 10 is actually a variable. So we can say number of tries equals 10 for I in range of number of tries. We can actually print I. So range is a very useful function in Python. Okay, we're going to fly through while loops, break and continue. So many typos. We're going to fly through while loops here, break and continue. I think they're going to resonate with you guys because I want to start talking about the homework. So here, a while loop, the purpose of this code, it's very similar to a for loop in that it executes segments of code iteratively. So it'll apply this block of code each iteration of the loop. So it's just like a while loop in that sense. However, here it will just complete. It'll go on indefinitely until the condition is true. So we say while condition. So maybe we're talking about number of tries. We could say while guess does not equal number. While the guess does not equal the random generated number, then keep asking them for more tries. So let's look at that before I get to this warning statement. Let's look at what a while is. So we have while true, print 1. Oh, I was going to use that. There we are. Print 1. And this will print the value 1 as long as this conditional statement is true. Now we have a problem here. Does anybody know what it is?
We didn't put a proper end to it or tell it how many times to print it.
That's exactly right. So this little spinning dial here means this code is still executing. And if you scroll on this output here, it's continuing to print ones. There's lots and lots of ones here. Not just a few, but very, very many. And it's continuing to print those because the statement still is true. So we're going to stop that. We're going to kill it. I'm going to hit this little pause button. And I'm actually going to clear this output. There we are. So while loops, you have to be careful because you can accidentally make something called an infinite loop, which this is an infinite loop. Which essentially means that your code will just run forever. And that's not good. You want your code to reach an end part of your program. Your goal is to see output from your program. While loops running forever can cause issues. So let's think a little more about how these while loops work so we can understand situations in which we might accidentally. Usually you're not just using a Boolean, true or false. Usually you're using a condition. So maybe we have the value 10. My value equals 10. And we say while my value is greater than 0, it's wild that I already knew what I wanted to do here. Print my value. And what we're going to do is, I was actually going to use the minus equal, but this is fine. We're going to print my value, and then we're going to subtract 1 from my value. So we're going to take 10, and we're going to subtract 1 for it. And don't forget, we have to reassign that. If we remember, it's an immutable value, so we have to reassign it back to this value. And then we're going to come back to the while loop, and we're going to iterate through that. So eventually, what we're going to get is a countdown here. So we can even call this maybe rocket launch countdown code. We created some code to launch a rocket. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. Here our loop ends when this condition evaluates to false. So at the end of this loop, we have 1. 1 minus 1 is equal to 0. And when we pop back up to this while loop, because this all happens in an iterative circle, 0 is in fact not greater than 0. So our while loop terminates and ends, and we exit the loop. We exit the loop, and this print statement executes. Okay, here's another example of using a while loop. Count is equal to 0. We can count up, we can use the plus equals. As long as count is less than 5, we're printing count is, and we're seeing the output of that. So the count is 0, and then it's 1, and then it's 2, and then it's 3, and then it's 4. 5, when it gets to 5 here in this loop, 5 is not less than 5. So it exits this loop and ends. So while loops need an ending condition, a terminating condition. Let's try it here in this code. Try to modify, spend a couple minutes modifying this code from above that we were working on, but implement it with a while loop instead of a for loop, and do it for we'll do this really fast because I know some of you have already done that. If you've already done that, try this, you try it instead. You can write a loop that prints numbers 1 to 10, modify it to skip numbers skip multiples of 3. Oh, we haven't talked about continue. Nope, we already did. We're already doing number 3. We'll just do this together. Let's just do this one. All right. So we have a number to guess here. We have our random int. Number of tries is equal to 10. And user guess, we're asking them to guess a number that is between 1 and 10. We can say while user guess does not equal our number guess, do stuff here. So this is our stuff we wanted to do. If user guess is equal to number guess, then we print congratulations, you guessed the correct number. Elif, we're going to print too low, try again. Else, we're going to print too high, try again. And we do need to ask the user for more input at the end of this code. So we will guess again. There we are. This. Okay, this won't exactly work the way we want it, but that's fine. So guess a number between 1 and 10. We're going to guess 1. It's too low. Try again. We're going to guess 3. Too high. We're going to guess 2. And it ends up printing this. Why is it printing this? You are out of tries. We've lost the game.
That's different than my issue. Mine issue, because mine looks pretty similar, but mine had it is when it runs that even if you guess it right, it makes you go through all 10 tries. But
what's your while statement?
The opposite.
Your
I mean,
condition here.
Different verbiage, but the same thing. Number of tries 10. Ask for user input, and while number of tries is less than 10. And then I have at the right after the user guess, I had it roll up the number of tries by 1. So I did have to set it as a variable that started at 0.
So it will go through every single one of your number of tries.
Yeah, I couldn't think of a way to kill it when you win.
Minus equals. This is what you have, right? Number of tries. There we go. Pretty close, right? Without the rest of
Yeah.
the code. Yeah, I
Yeah.
just took out the while
Took me a
statement.
second.
So the number of tries, what this will say is, hey, I have 10 tries, go through this loop. Oh, now I have 9 tries. But to your question, how do we actually stop? What's the stopping condition?
I don't have one.
So this would be, there's a couple different ways we can do that. I'm going to leave this here because I'm going to talk about breaks and continue, which could be, what you guys will learn in this class is that there are many different ways to do the programs correctly. There's no one solution or no proper way to do it. There's just different approaches, and they all work equally well. So this is a equally well working one when we include something called the break statement, which we will do here in a minute. A different way we could have done this is we could say, if the user guess does not equal the guess, if what we got from the user is not equal to what the guess is in the computer, the number that they should be trying to guess, then continue to ask them. But if they are equal, then this while loop will terminate and we will no longer be asking them for input.
So I have mine in a little bit different order, and it actually kind of gives me an idea. So on your while, it's only going into the while if it's not equal to the number of guess.
That's correct.
But immediately after, it checks to see if it is equal, but we already know it's not equal. So if we take that, the if line,
You're right.
the while statement, and have it check for that first, and just never go into the while statement if it's correct.
You are right. This is something we could probably put at the end, and oh look, it's going to solve our other problem. If user guess is equal to number guess, then congratulations, you've guessed the correct number. Else, if they're not equal and this while loop is done, that must mean that they ran out of tries, don't you think?
Yeah.
All right, let's try this. This is looking pretty good. Guess a number between 1 and 10. 1. Oh, too low. Try again. 10. Oh, too high. 5. Too low. 7. Too low. 9. Oh, congratulations. We guessed the correct number. Good. We're starting to build some like decently sophisticated pieces of logic now. And this is really how you guys will build all of your programs. You will be telling the computer what to do, how to operate it. You're the designer, the architect of the way that this program should operate and the flow that it executes. So when your code is wrong, there's 2 different types of errors. We'll talk about them. There are semantic errors and there are syntactical errors. And there are times where the program is executing properly in accordance with how the computer should execute the program, but maybe it's not logically correct. Maybe it's not, it looks like it's running correctly, but really there's an issue in the way that we design that as a human. So those are some of the most challenging errors to find. Okay, break and continue. Let me move this code down because we're gonna talk about it in the break and continue. For break, there are 2 keywords that are quite useful when working with loops. One is break and one is continue. Break will actually exit the loop prematurely, and continue will skip the current iteration and move to the next loop. So let's talk about break. Sorry, I thought I had these in separate cells here. So in break, if we have this example here, we're saying for I in range. Remember, range creates a list of numbers from 0 to 9, a list of 10 numbers. We're saying if I is equal to 5, then break. I should have said, what do you guys think? I'm going to delete these. What do you think the output will be here? Oh man, I already have it on that slide, so I guess I'll just print this one. I have something very similar. So the output here is 0, 1, 2, 3, 4. So when we hit I equals 5, when we hit 5 from that list, we're saying break, which means get out of the loop, come out of the code, and actually break stops execution in the loop immediately and returns to this line of code. So the next unindented line, so we don't even hit this print statement. We just say stop immediately when I equals 5, break, don't loop through any more numbers, don't continue, don't pass go, don't collect $200. So this, where we could use that in your while loop here is we could say break. We say while number of tries is less than 10. If the user guess is equal to the number of guesses, break out of this while loop. Otherwise, if those are not equal, print it's too low or print it's too high, and you know, let's gather some user guesses. So let's try this. Oh, I probably have to reset this. There we go. Why is that not? Oh, number of tries is greater than 10, sorry. Is greater than 0. 0. There we go. Our numbers are the same. You know, we'd have to do the whole, we have to reset our user guess. There we go. So guess again. So we guess 10, 5, and then we must have gotten it. There's clearly some work that we maybe need to do there. I'm not quite sure why that didn't work. I'm trying to rush through that, but hopefully you guys understand the concept of the break statement. Any questions on break? It just says get out of the loop. We're not going to do that. There are other situations where we don't necessarily want to skip the entire iteration. Maybe we just want to not work with that number, or not work with that row, or not work with that piece of data, or do something. We don't want the following pieces of code to execute. So that's when you would use a keyword called continue. And continue skips the current iteration and moves to the next. So in this code, we say for I in range 10, and then we're taking I modulus 2. So we're taking that number divided by 2, and if it equals 0, we're going to continue. Otherwise, essentially, it's going to print I. What is this code essentially doing?
It's our odd even thing again.
Exactly. That's exactly right. So here's our odd numbers. And if we change this to a 1, we could get our even numbers. There we are. So here's our odd numbers. It's saying if I modulus 2 is equal to 0, continue. And what continue does is it says, forget all of this code. Maybe I've got more code here inside of my loop. Ignore this, pop back up into this for loop here, and pick up the next number. And let's look at that instead. So continue will not execute any of the rest of the code within your code block if this condition is met. So if this condition is true, then continue will skip that iteration for that number. Okay. Might be worth trying continue and maybe exploring a little bit of nested loops. I'll share this with you guys. We talked about nested loops a little bit in the for statement, in the if statements. Nested loops are essentially when we put a loop inside of another loop. And this is very, very commonly used. In this case, we have 2. You could have 10. You're going to run into some computational issues if you have a data set of any substantial size. However, a good exercise for you guys might be to write a nested loop that creates multiplication numbers or prints this pattern. However, it is 8 and I wanted to switch to the assignment by 8. So let's take a 5-minute break. If you guys would like to, feel free to try these exercises on the break. If not, I'm sure we're going to apply some of these concepts in the homework. So we'll switch to that. Let's come back at 8:05 and then we'll do assignment 1 together.